So you've seen a video now on data modeling. This is kind of a simplified example of some data modeling. And this is a slide that we looked at early on in the term. Just a very simple schematic test, kind of a sketch for a basic database setup, as it says here. And if it were a company like Amazon, you'd have obviously the product database would be part of the setup. There's a website as part of the setup. The idea of database modeling is to sketch out what data are going to be collected, where, and then how each relational database is linked. Okay. And the other part of figuring it out is, where is different data, where are different data being stored? And we did talk a fair amount about storage, I know, but I'm just going to refresh your memory. We talked about the cloud, and this is data centers for Amazon all over the world. And so not only, just to make the point that not only would your database modeling include, how the different types of data relate, where they're captured and everything else, but it would also include physical location, because that's going to be part of the setup and how you set up communications between different databases and data warehouses. Okay, so it's a spatial issue as well. So that's, we've now talked about predictive modeling and forecasting with using data, and we've talked about database modeling in terms of the architecture and physical location of data. And I now want to talk about data science. Here's a definition of it from Wikipedia. I like definitions, as you know. An interdisciplinary field uses scientific methods, processes, algorithms, and systems, and some would argue creativity and empathy and talent, to extract knowledge and insights from many structured and unstructured data. Data science is related to data mining and big data. And you remember when we talked about big data, this is another slide that goes back to, I think, our second lecture. So much more data are being captured now, and not just consumer data, but just all kinds of data. You may recall I sent you guys an article a couple of weeks ago giving you an example of some correlation between mortality rates for the COVID virus. And I'm sorry to bring this up. I know it's a topic we probably all want to ignore. We've had enough of it, and I apologize, but there was a correlation between between particles in the air, unhealthy air quality, and mortality rates. So that's not a consumer database, right? That's a health-related example of doing a correlation between, I'm sure, probably hundreds of variables and mortality rates for COVID. And that's big data at work, and that's an example of air quality data being captured geographically and going into a database kept somewhere. Okay, so amount of data, recency of data times computing power is a lot of power, a lot of thinking power. to solve problems that haven't been solved before. And you end up with this thing called Watson, which some people refer to as artificial intelligence. But what's behind it is the people, the data scientists, setting up the correlations and really setting up the how the data are related and what's really looked at. It's not just done automatically. And when we get back to the world of marketing, we know that we use data in marketing to target the right people and optimize our communications. And this is the kind of the circle of database marketing here. Now I'm going to break, and we're going to listen to, again, I think a pretty interesting TED Talk. It's only about 8 or 9 minutes from this gentleman. He speaks English very well. He has kind of a thick Spanish accent, but if you listen carefully, you'll get what you need to get. And I think he has a nice high-level view about data science being more than just some kind of glorified accounting. It takes a lot of creativity and, as he says, empathy.